Now 24, the vector BC is drawn in the direction of 24, that is 24 is what? 24 is corresponds to C, that is angular position of the mass C. Next, after C, you have 0.1 times of my. So 0.1 times of my we can draw now itself, or let us go to the next known value, that is 16. So you can draw this in any order. So it is not necessary to follow exactly this order. In any order we can do this. So next let us take the known value as per this diagram. So let us take 16. So 16 corresponds to 16 is the centrifugal force of the mass D. Now mass D is in this direction. Mass D is in this direction. Now draw 24, not 24, 16. Draw 16 kg meter in this direction, that is in the direction of D. Next value which is known again is 0.1 times of my. So because my we have already calculated, the magnitude of 0.1 times of my. Now my is shown in this direction. So now draw this vector in the direction of my, in the direction of my. Now we are at the point E. Now we have drawn all the force polygon, but all the force vectors, but polygon is not closed. Now we have to close the polygon, because for the balancing of several masses in different plane, the force polygon must get closed. The meaning is that there are no unbalanced residual forces left over. Now close this polygon, join E to O. Join E to O. Give the direction to this vector such that it closes the polygon. It closes the polygon in the cyclic order. That means downward arrow mark you have to give. Now measure the distance OE. By measurement OE, for example, OE may be some 20-25. Convert back to kg meter. That means you multiply it with the suitable scale. Multiply it with this value. That means whatever the distance you get, the distance should be multiplied with this in order to get the value in terms of kg meter. Now 0.1 times of mx. 0.1 times of mx equal to 35. This value is after conversion. 0.1 times of mx is equal to 35.5 kg meter. Now calculate mx. So mx is equal to 355 kg. Now measure the value of theta x, that is the angular position of the mass. How do you measure the angle? Because the vector is in this direction, measure from its root. Always measure the angle from its root, because it is in this direction. So from the horizontal, from this reference plane, so measure this angle in the clockwise direction. You can measure, as I told earlier, either in the anti-clockwise direction or in the clockwise direction, because clockwise angle measurement is easy, so we are measuring it in the anti-clockwise direction. There is no standard rule that you have to measure only in clockwise direction or in anti-clockwise direction. So measure this angle. So after measurement, so you will get 145 degree. That is the angular position of the mass x. Now after the measurement, we have to show the angular position of mass x into the space diagram. Earlier we had, please remember, we had shown only A, B, C, D first. After we found my, theta y, we drew this, we showed the position of the mass y. Now because just now we have determined the position of mass x, magnitude and position of mass x, now we will show the position of the mass x. That means in this direction, show the position of mass x. And this completes the solution.